Hey, welcome back to Eigen Designs. About a month ago, I set up this SawStop table saw in my shop and I've been absolutely loving it. But I've been needing a crosscut sled to fit this particular table saw. So in today's video, we're going to be building a crosscut sled, but putting a little bit of an interesting twist and adding some features that I have never seen anyone else integrate into a crosscut sled. So if you want to see how I built it, then stick around and I'll show you how. Crosscut sleds are a great utility jig to have around the shop because it allows you to make a perfect 90-degree crosscut using your table saw. Now, I've actually made one of these before for my previous table saw, which I'll link here if you want to check that out. And because I ended up using this sled thousands of times, I developed an appreciation for what features I really needed to have and which ones I wanted to change in this particular iteration. So some of the things that I liked was that it was highly accurate. I liked this stop block feature as a part of the extruded aluminum fence. There was no play in the sled, and I liked how deep it was for some of my bigger projects. But I didn't like that there wasn't any blade protection, and I didn't really use the T-track that was embedded into the sled. There wasn't any measurement on it, and I wish there was more space to the left of the blade. I also noticed that the sled had some sharp edges that I didn't round over. And obviously for the SawStop, I can't have a metal fence because that'll activate the safety feature of the SawStop. Now, you can get really complicated with your crosscut sleds. You can add in ability to do 45-degree miter cuts. You can have adjustable fences. I have found for me personally with my workflow, simplicity is king. I want to keep this one simple and add in the features that are going to help me complete the projects that I do in my workshop. The materials for this build are pretty straightforward. I'll be building the sled out of 3/4 inch birch plywood, and then for the fences, I'm going to be using some leftover 1-inch birch plywood that I have left over from the CNC table build that I had a few months ago. I don't really have another use for it, and I thought that the sturdy 1-inch fence glued up on itself would make a really strong fence. So before cutting the sled itself, I took some measurements of the table saw, trying to maximize the available space to the left of the blade for some of my larger projects. That total width was about 32 inches, which leaves about 22 inches to the left of the blade. I also measured the height of the blade so I could calculate how tall the fence needed to be for the crosscut sled. With all the measurements taken, I ripped the 3/4 inch birch to 32 inches wide to create the base of the sled. With the sled cut, I turned my attention to the front and rear fence for the crosscut sled. I set my table saw fence to 5 inches and ripped the plywood that was going to be used to create the front and rear fence. I did end up deciding to make the front fence out of 3/4 inch birch instead of the 1 inch to save on weight. Once all the pieces were cut, it was time to glue them up. I got out my parallel clamps and my Titebond glue and began to glue up the front and rear fences together. Now, one of the tricks that I'm using here is to clamp up each of the fences against a level to ensure that as they're drying, it dries straight and not curved. I also decided to shave 1.25 inches off of each of the fences just to reduce the overall weight of the crosscut sled, because this thing's going to be pretty heavy. Once that was done, I set my table saw fence to the same depth as the T-track that's going to go in the back fence, and then I began to rip a slot in the top of the fence. You can use a dado stack if you have that. Given that this is a pretty quick job, I thought that doing it with the table saw blade would be a little bit quicker, but you can also use a router table if you have that as well. Once the slot was cut, I did a quick dry fit to make sure that the depths were right and the widths were right. Looks to be a pretty good fit. This is what's going to be used for the stop block in a later step. The key to a good crosscut sled is to make sure that the rails that you use are a snug fit in the miter slots that you have for your particular table saw. The best way that I found to do this is just trial and error. So what I did here was I took a scrap piece of plywood, and through trial and error, I got my table saw fence set to the right width so that there was very little play in the piece of wood that was cut. Once I was happy with the results, I then switched over to my hardwood maple stock I'm going to be using for the actual rails and began to cut those. Now, I only need 2 for the crosscut sled, but while I have the fence set to this right length, I'm going to cut a few extra pieces because inevitably I'm going to be building some jigs down the road that will use these rails in the future. For this next step, I'm going to be using these nuts as a spacer for the miter slot so that the rails, once they are installed above the nuts, will be just proud of the table. This will allow us to glue the rails to the bottom of the sled in the next step. I'm using wood glue for the rails because it's a very strong bond to the bottom of the sled, but you don't want to use very much because you don't want any of the squeeze out getting on your nice cast iron tabletop. So once the rails are back into the miter slots, I use the table saw fence as a reference and I put the sled gently down on the tabletop and then put some weight on top of the sled to allow the rails enough time to dry. And in case you're wondering why the rails that I'm using are so shallow, this is the reason why. There's about a millimeter of clearance between the rails and the outfeed table. I used a flush trim pull saw to remove the excess rails hanging over the sled. And then I used a 1/4 inch roundover bit on my palm router just to soften the edges of the sled. I've seen a number of crosscut sled designs that have a ruler on top of the fence where you would have your stop block, but I have not seen anybody use a CNC to engrave a ruler into the actual face of the sled itself. So what I decided to do was to have an ascending ruler on the right-hand side of the table saw blade, and then on the left-hand side of the blade, have it descending away from the blade. I was able to create both of these designs relatively quickly because Fusion 360's design software has a normal snap to grid pattern that is in inches already. So I was able to create a design and then rapidly create a toolpath to carve out this particular design. Before carving, I actually had to temporarily remove my riving knife so that I could make a reverse plunge cut with my table saw to show where the kerf was going to be on my crosscut sled. Once I had that identified, I then temporarily put my rear fence in place to mark out where the start point of the CNC cutting needed to happen. So that's a nuance that I want to point out. For the right side of the blade, the starting point had to be the right side of the kerf to make all these measurements line up. And then in the next part, whenever I cut the ruler on the left-hand side of the blade, similarly, the origin or the 0 point has to be on the left side of the kerf. Otherwise, all your measurements are going to be out up to 1/8 of an inch. So if you're looking to replicate this, just pay close attention to where you're setting your 0. Once everything was cut, I went and verified with a tape measure, and the inch markers are in the exact middle of each of the engravings. So this thing could not have been more spot on. I was really happy with how it turned out. Now, one thing I will say is that the numbers were pretty hard to read, so I decided to mask off the area and take some black spray paint and just give it a once over, let it dry, and then I came back in with some sandpaper and sanded off most of the black paint, but it left behind all the black paint that was in the indentions. It's not a perfect method because you do take off a little bit of the veneer, but it did make the numbers pop. Attaching the front fence of a crosscut sled is pretty straightforward. It doesn't need to be aligned with anything, so you see me here just using some compression clamps, a countersink bit, and then some screws to hold it in place. I think I put a total of 5 screws. Just make sure that you don't put anything metal near where the blade is going to be penetrating. Once that front fence is fully secured, you can then make a penetrating cut all the way through the fence and into the crosscut sled, because you're going to be using the blade as a reference point to help you set the initial rear fence before beginning the calibration process. So here you see me doing that. I get a long square out and I'm just adjusting the fence, which is not clamped down or screwed in yet, and trying to get it as close to 90 degrees as possible before beginning the calibration. Then I slide everything back to where the back edge of the crosscut sled just overhangs the table saw itself, and I use some clamps to hold it in place, and then I attach a screw into each corner. One's going to be the pivot screw, the other one is going to be the adjustment screw for the calibration process. Now, the calibration process we're going to be using is called the 5-cut method. Essentially, you're looking to identify the error in your fence calibration by making a series of 5 cuts. The first side that you cut, you take a small strip, you rotate it clockwise so that the side that you just cut is now against your fence. And you repeat that until you are all the way back at the very first side that you started at. Then you cut a strip. This will be your 5th cut. And you take that strip and you measure the width at the very top and the very bottom. Any error that you have in your system would have been magnified across each of the 5 cuts. So here at the very top, my width at the top, which we're going to call A, is 1.037 inches. At the bottom, we're going to take another measurement, and we see that it is 1.032. So the difference between the top and the bottom is about 5/1000ths of an inch over the course of 4 cuts. So if you divide that by 4, the tolerance is about 1/1000th of an inch per cut. Now that's perfect for me. I decided not to calibrate it any further, but the 5-cut method would show you how you would adjust your fence if you needed to. So using my numbers as an example, my EPI, or error per inch, ended up being 0.000104. To calculate the adjustment of how much you need to move your fence, you take that EPI and you multiply it by the length of the pivot screw all the way to the end of the fence, which in my case is 27. So I would need to adjust my fence 0.0028 inches clockwise in order for it to be perfect. So William Ung has a really good video if you want to see that in more detail. I covered it very quickly, but that's how you calibrate your crosscut sled. So with the hardest part behind us, I decided to flip the crosscut sled over and apply a little bit of paste wax on the bottom, just to help reduce that static friction whenever you're sliding it. And I also put a coat of wipe-on poly. Now, I normally wouldn't put a coat of poly on a crosscut sled, but I thought it would help the discoloration of the sanding because I kind of went through some of the top layers of veneer, and the poly helped cover that a little bit. I then took some scrap plywood and did 2 things. I created a stop block, and I also created a protective measure for the blade on the back side of the fence, so I know where not to put my hands. This is the blade guard on the back side of the fence, and this is something that I wish I would have had on my first one. I then used my crosscut sled to cut some channels into the stop block so that I can actually use the top of the T-track to help slide it around. You'll see more of that in just a second. The final crosscut sled turned out fantastic. It's definitely on the larger side because that's something that I wanted for my shop. And the inlaid ruler on both the left and the right side of the blade is something I'm going to get a lot of use out of. I like the design of my stop block because it allows me to securely put it in place and make repeatable cuts whenever I need to. And then whenever I'm done or not using it, I can actually flip it around and it'll not be in any obstructive way of using the entire footprint of the crosscut sled. The blade guard is also a really nice addition because it'll remind me not to put my thumbs or fingers anywhere near the blade. I know I have a SawStop, but I never want to test that feature out. Now, as one more barrier of verification, I decided to set my stop block to 3 inches, put a fresh edge on a scrap piece of wood that I had lying around the shop, and make a cut and verify the measurement with a tape measure just to see how close it really was. And whenever I took the tape measure to it, it was exactly 3 inches. So I'm feeling really confident about the ruler that's been inlaid onto the board. I think I'm going to get a lot of use out of that, and that might be a feature that I see other YouTubers and other woodworkers start to adopt, at least those that have CNCs, because I think it's really functional. And when my crosscut sled is not being used, it's now going to live in a little nook between my workbench and my SawStop. And that's going to be it for this particular video. I had a lot of fun making this crosscut sled, and I know I'm going to get a lot of use out of it, but I'm curious what you think of the ruler that's been inlaid onto the crosscut sled. Leave your comments in the section below, and I'll see you on the next one.